At this very moment, you are hurtling through space at roughly 1.3 million miles per hour. The Earth orbits the Sun circles the galactic center, and the entire Milky Way galaxy is falling through the cosmos. But we are not drifting aimlessly. We are being pulled across the universe by an unseen leviathan, a massive gravitational anomaly so immense that it dictates the motion of thousands of galaxies. This invisible colossus is known as the Great Attractor, and its existence is one of the most profound mysteries in modern astrophysics. The first hints of this cosmic migration emerged in the 1970s. Astronomers studying the cosmic microwave background, the residual heat left over from the Big Bang, noticed a subtle temperature variation across the sky. One side of the universe appeared infinitesimally warmer than the other. Researchers soon realized this was a Doppler shift caused by our own motion. The Milky Way and our neighboring galaxies, collectively known as the local group, were speeding in a specific direction, defying the uniform expansion of the universe. Scientists calculated that our galactic neighborhood was moving toward the constellation Centaurus. Yet when they pointed their optical telescopes toward that region of the sky, they found nothing that could account for such a massive gravitational pull. To generate a force capable of reeling in thousands of galaxies, an object would need to possess the mass of tens of thousands of Milky Ways. The destination of our cosmic journey remained shrouded in darkness, presenting a monumental puzzle for cosmologists. The culprit behind this blindness was our own galactic home. The target of our trajectory lies directly behind the galactic plane of the Milky Way, a region astronomers call the Zone of Avoidance. This area is choked with dense interstellar dust, gas, and a brilliant concentration of stars that effectively block all visible light from beyond. Looking through the center of our galaxy is like trying to observe the distant universe through a thick, illuminated fog. The Great Attractor was hiding in the cosmos's most perfect blind spot. To pierce this veil of dust, scientists had to abandon traditional optical astronomy and look at the universe through different eyes. Radio waves and X-rays can pass right through the dense particulate matter of the galactic plane without being scattered or absorbed. By launching X-ray observatories into orbit and tuning massive radio dishes on Earth, researchers began mapping the invisible gravitational landscape hidden behind the cosmic fog. The curtain was finally lifting on the Zone of Avoidance. What those specialized instruments revealed was a staggering concentration of matter. Deep within the obscured region, about 150 million light-years away, astronomers detected the Norma cluster. A light-year is the distance light travels in one Earth year, roughly 5.8 trillion miles, making this a relatively close neighbor on a cosmic scale. The Norma cluster is a massive, dense grouping of galaxies emitting intense X-ray radiation, a clear signature of extreme gravitational forces crushing interstellar gas. For a brief period, the Norma cluster seemed to be the answer, but as X-ray surveys became more precise, researchers discovered a troubling discrepancy. While massive, the cluster simply did not contain enough matter to account for the immense pull acting on the Milky Way. The math did not add up. The Norma cluster was merely the tip of a much larger cosmic iceberg, a single feature in a vast, hidden topography of mass. The missing mass problem pointed directly to dark matter, This enigmatic substance does not emit, absorb, or reflect light, interacting with the universe almost entirely through gravity. Scientists believe that dark matter forms the invisible scaffolding of the cosmos. In the region of the Great Attractor, massive dark matter halos anchor the visible galaxies, multiplying the gravitational pull far beyond what the glowing stars and hot gas alone could generate. Even with dark matter factored in, the Great Attractor region was not the final destination. As astronomers mapped further out, peering deeper into the radio and X-ray spectrums, they found something even more colossal. Located over 650 million light-years away, sits the Shapley Supercluster, the most massive concentration of galaxies in our local universe. The Shapley Supercluster is so gargantuan that it is pulling not only the Milky Way, but the Great Attractor itself toward its center. This cascading gravitational hierarchy forced cosmologists to rethink the very nature of cosmic structures. In 2014, a team of researchers mapped the peculiar velocities of thousands of galaxies, tracing their flow through space. Their findings redefined the boundaries of our galactic neighborhood. They discovered that the Milky Way, the Great Attractor, and roughly 100,000 other galaxies are all part of a single, immense structure. They named this structure the Laniakea Supercluster, a Hawaiian word meaning immense heaven. Visualizations of the Laniakea Supercluster reveal a breathtaking cosmic anatomy. Instead of a static collection of stars, it looks like a vast branching watershed. Galaxies flow along invisible filaments of dark matter, streaming like rivers down a mountain, all converging toward a central gravitational basin. In this grand map, the Great Attractor is not a solid object or a singular monstrous black hole. It is the gravitational focal point, the lowest valley in our local region of space-time. Understanding this structure radically shifts our perspective on humanity's place in the cosmos. We are not perched on a stationary rock in an empty void. We are active participants in a dynamic, flowing universe, swept up in a cosmic current that spans hundreds of millions of light-years. The realization that our entire galaxy is just a single drop in a majestic, universal watershed instills a profound sense of scale and cosmic humility. This flowing architecture is a localized manifestation of the cosmic web. The cosmic web is the fundamental, large-scale structure of the universe, a sprawling network of dark matter filaments woven across billions of light-years. Where these filaments intersect, matter pools together to form massive galaxy clusters and superclusters. The Great Attractor is simply a particularly dense node in this infinite web, a nexus where multiple cosmic rivers of gas and galaxies collide and merge. The forces at play within these nodes are almost beyond human comprehension. As galaxies plunge toward the gravitational center, they accelerate to terrifying speeds. When these massive galactic clusters collide, the friction between their interstellar gases generates shock waves that heat the matter to tens of millions of degrees. These are the colossal energies detected by our X-ray telescopes, the glowing embers of cosmic collisions echoing through the dark. Charting these deep space currents requires extraordinary precision. The universe is constantly expanding, driving galaxies apart. To measure a galaxy's peculiar motion, its true gravitational drift, astronomers must first subtract the overwhelming velocity of cosmic expansion. It is like trying to measure the speed of a single fish swimming upstream in a rapidly rushing river. This delicate subtraction demands incredibly accurate distance measurements, pushing the limits of our finest telescopes. As observational techniques sharpened, the map of our local universe grew even more complex. Researchers discovered that the gravitational pull of the Laniakea Basin was only half the story. In 2017, astronomers identified a vast, empty region of space on the opposite side of the Milky Way, almost entirely devoid of galaxies. They named this cosmic void the dipole repeller. We are not just being pulled by the Great Attractor, we are simultaneously being pushed by this immense vacuum. In the vacuum of space, a lack of mass creates a relative repulsive force. Because the dense regions of the universe exert a strong gravitational pull, the empty voids effectively push matter away. The Milky Way is caught in the middle of this cosmic tug-of-war, fleeing the desolate expanse of the dipole repeller and accelerating toward the dense, matter-rich node of the Great Attractor. This dual action perfectly explains the velocity and direction of our galactic flight. This intricate choreography of pushes and pulls reveals a universe that is far more interconnected than previously imagined. The void and the supercluster are not isolated features. They are two sides of the same gravitational coin. The emptiness of one region directly influences the density of another, orchestrating the movement of trillions of stars. It is a sublime cosmic balance, governed entirely by the unseen geometry of space-time. Yet, despite our rapid plunge toward this gravitational nexus, the Milky Way will likely never reach its destination. A counteracting force is tearing the cosmic web apart. Dark energy, a mysterious phenomenon driving the accelerated expansion of the universe, is stretching the fabric of space itself. While gravity pulls local galaxies together, dark energy pushes the grandest structures away from one another at an ever-increasing rate. This cosmic expansion creates an ultimate speed limit for gravitational collapse. In a few billion years, the relentless stretching of space will overpower the gravitational bonds holding the Laniakea Supercluster together. The cosmic rivers will dry up. The galaxies streaming toward the Great Attractor will be carried away by the expanding void, forever isolating our local galactic neighborhood from the distant clusters we are currently racing toward. The fleeting nature of these superstructures makes our ability to map them all the more remarkable. Humanity, bound to a tiny rocky planet orbiting an average star, has managed to deduce the shape of invisible empires. By analyzing faint radio whispers and distant X-ray glows, we have charted the invisible gravitational structures of the local universe, transforming a terrifying unknown into a beautifully detailed map of our cosmic home. The quest to refine this map is far from over. Next-generation observatories like the James Webb Space Telescope and upcoming massive radio arrays are peering deeper into the zone of avoidance than ever before. These highly sensitive instruments are designed to cut through the densest dust clouds, searching for hidden dwarf galaxies and mapping the dark matter filaments with unprecedented resolution. The ghosts in the galactic fog are slowly being brought into the light. Every new observation adds a vital piece to the puzzle, clarifying the intricate web of mass that surrounds us. Astronomers are now mapping the boundaries where Laniakea meets neighboring superclusters, like Perseus Pisces and Coma. They are defining the cosmic continental divides, the exact ridges in space-time where the gravitational flow shifts from one massive attractor to another, giving us a true three-dimensional atlas of the cosmos. The Great Attractor remains a testament to the power of human curiosity. It began as an anomaly, a terrifying phantom force dragging our galaxy into the dark. Today, it stands as the majestic heart of our supercluster, a brilliant demonstration of gravity's power to weave the universe together. As we continue our long journey through the void, we do so not as lost wanderers, but as cosmic cartographers, forever mapping the invisible currents of the great unknown.